Там-то в 2 раза больше.
You want to say a few words before we start?
Yeah,
Okay.
kick off like 5 minutes and then straight to
You want to kick off in 5 minutes?
Yeah, about it.
Okay.
Yeah, I'm gonna start talking in like 2 minutes and then I'm gonna do like so yeah, we'll do questions afterwards. Just hold the questions, talks back to back because I'm hoping that people will come and talk to you like about your research rather than have like short format questions, you know?
All right, let's take all questions after all talks.
Perfect.
Like somewhere there.
Yeah. We're gonna have
we're just gonna hang it out there.
perfect. Sounds good.
All right, awesome.
Good stuff. Good stuff. All right, let's get started. Hello, everybody. I've met a lot of you. Thank you so much to Netflix for hosting this. This is awesome. Netflix is if there's anything that you feel like you want to talk about, please send them. We have a speaker submission form. So there has been a leadership change for OWASP Bay Area. I'm very busy, so he's going to still involved in chapter leadership. You guys are all helping me set up great meetups, and I couldn't running them going forward, and I also what you guys want. You're all OWASP Bay Area members. What do you want from your chapter? Are there projects that you want to kick off? Let me know like what you want from your chapter.
I'm not really Netflix, but I'm the anointed one for the evening. So I just want to say welcome to everyone. Thanks for coming out to Netflix. For some, it might have been a longer journey. I know we're kind of down at the bottom of South Bay sometimes. I think it's a fun program tonight. I'm really excited that we're going to have some demo tables out later. That's right after the talks. Is that right? Yeah. So our security teams here do a lot of open source projects, and off a few of them tonight. In some of our open source projects, or just generally how we do things here at Netflix. Often we get fun questions around how we handle security or how we handle it in a way that sort of fits into the Netflix culture. All great questions, and I'm sure anyone. For myself, I'll be around all evening as well. So that's all I'm going to say. Enjoy the evening, and thanks for coming.
this meetup a little differently. We're still playing. We're going to do have questions. We definitely want to have those answered. As Bryan mentioned, we also have a few. With that, I will give it over to Ilya and Maxim. Thank you.
Well, guys, so today we're gonna present our talk about collecting email addresses and passwords for Exchange server. I don't know how many people here are using Exchange server at their organizations. Yeah, so it's probably will be interesting for you. But we are not trying to hack a server because it's really hard, and we trying to find something to shift it closer to client. So this presentation we presented like 2 months ago on a BlackHat AGA, and it's the second time when we gave it. So hope it will be interesting for you as well.
So hi, my name is Max, and I'm working for the company here in Bay Area called Shape Security.
My name is Ilya Nesterov, and I also work at Shape Security, and most time I work on trying to break things or to build things that help me to break other things.
Yeah, I came to Shape Security from Trend Micro, the antivirus company, so where I was working like for a decade. And we're going to talk today about the protocol, which is interesting. And we're going to show you something which will maybe blow your mind, but we'll see. So email, what can be simply the email? So email is quite long. So actually email brought the internet began from the emails, and a lot of people using emails every day, right? And there is nothing really special about emails because it's also researched how the email works, how the delivery works, what the spam is, and we thought we can't find anything interesting over there. And but still, in case of like you use an email and you know how email works, so you know that email is kind of easy to use but kind of difficult to configure. So when you configure your email address, for example, in your phone or in your, some other device, you usually have to know many different things about the email address, like email server, SMTP, POP, IMAP, port, certificate to use, not certificate, and such a thing. So these things usually tricky, and because of that, there is a protocol which called AutoDiscover, which can really makes life easier. And I'm sure that everybody who sits here used this protocol before, but not everybody knows that this protocol exists. I found this protocol for myself when I was doing the open source project called paranoid.email. This is a project for encryption for the emails, so you can, Google it and run this project with Ilya for some time. So, and when I was trying to configure my server to make the life of the users of my project easier, I found out this protocol exists, and I also found out this protocol got a problem. Next slide. So this protocol was announced in 2006 unofficially by Microsoft, and it was just some kind of upcoming feature of the Exchange server. And in 2008, this protocol, next slide, 2008, this protocol was documented and shown as an official protocol on the Microsoft products. So that time, the first document of this protocol was released with a .01 version. In 2009, the Thunderbird decided to follow the Microsoft and also delivered the same functionality protocol, which also help users to configure their email address in an easier way. So, and 2010, this protocol was reached and delivered as a part of the protocol called link server. So actually link server, it's a business part of the Microsoft products, which help the different products exchange information between the products, and also this protocol used a lot now in the Skype. And in 2017, we discovered with Ilya that this protocol got a problem, and we're going to talk about this problem now. Actually, what can be easier than just to use auto-discover protocol? So this protocol works in a way like you have a server inside a network, and this server propagates this information inside a network about or outside the network as well, how to configure your client. So basically your client trying to connect to the server, get the configuration file, and this configuration file provide all information around how your client should communicate with the server. So I come up to this idea last year. I mean, I told you about the open source project I'm running, and why I decided to test the auto-discover protocol for vulnerability, because last year I presented on BlackHat USA the speech about the WPAT protocol. So this is almost similar protocol, but this protocol helps just usual user how to configure the proxy settings of your machine. And I found out that this protocol leak into the open internet a lot of information, which is not should not be in this way.
So how auto-discover protocol works, there is like two different parts. There is auto-discover server and a client. And client, in order to communicate with auto-discover server to get settings for email client, basically have to do it in two stages. So it have to define a list of auto-discover potential servers and then try to reach each server. And if attempts succeed, then it just get all these settings and use it in a client. So how defining candidate pool works is defined in different ways. So first of all, if you're inside a network and you can reach LDAP or Active Directory servers, so first of all, client will try to contact the servers to get information about auto-discover servers. And if it's outside of local network, it will try to derive URLs for auto-discover server from email address. And third attempt, it's trying to query DNS server for auto-discover SRV record. And if it's all failed, so there is another thing how it can do is just to send an authenticated GET request to URLs that also derived from email address. And then it prioritizes this list, right? So how deriving URL from provided user email address works? So you just enter in your email client email address and a password, and the client have to take a domain part of email address and construct two URLs. One URL is contains HTTPS domain derived from email address and a path to auto-discover XML file. And another one is constructed by prepending auto-discover keyword to domain.
So I just wanted to add here, just to explain, usability here works in this way, like you open your, I don't know, iPhone or Android device, and instead of putting all information inside your device, like about SMTP server, everything like IMAP settings, port, you just put your email address and the password and click submit, and usually your device should be configured to connect to the mailbox.
Yeah, right. Yeah, so that's how deriving URL from email address works, right? So nothing interesting, but actually it's pretty simple, right? So you just deriving, you give an email address, you derive a domain part and a local part from it. you can probably come up with different algorithms how to do this, just probably by simply splitting using add character, or just, I don't know, trying to find this character from forward or from backward position. And that's it. Yeah, what can be run with this actually? But if you ever read an RFC about all these mail protocols, there's plenty of them. And this 4 is just probably third iteration. And it has about 30 years of history how to deal with email addresses. So if you can think about valid and invalid email addresses, and you can think about algorithms how you can split given email address to local and domain part. Let's say you do it for using by add characters, but add characters is allowed actually in a local part if you put it in a quote. But if you don't, then it's invalid address. So it's probably enough complexity in a protocol itself, especially that email address used to derive domain names and URLs and basically send requests to them. And when it's really important piece of a protocol when after discover clients send request to after discover URL derived from UML, it is authenticated request. So it means it has an authentication header, depends on which settings server can use. In most cases, it would be just basic authentication. If client ever contacted like LDAP or AD server, it may already know that it has to use an TLM authentication, which will be harder to crack, but in case of basic, it's just like a plain text, base64 encoded. So we decided to just try few different email client, and especially after discover client implementation, to find out whether they work okay or not, according to protocol. And we got a list of different valid and invalid email addresses like this, and created a test bed and tried to find some issues. And this is what we found.
So first of all, when we tested the list of the non-really standard email addresses for what we thought it can be not really standard for some of the software devices, we found out that in case of you use a Samsung native client for Samsung devices, in case of you use a email address like you see on on the screen, like tomconf77 example.com.au, and you're trying to add this device to the Samsung
Email address
to Samsung device, your Samsung device is going to make two different requests. The first request, actually, this is right, and this is how the AutoDiscover protocol described. So the request will be sent to the domain name, which is derived from the email address like example.com.au. And the second request will go somehow to the domain name like autodiscover.com.eu, which is wrong, because Samsung somehow misspelled the main part of the email address. We found this problem, and we tested this problem a little bit. So, and we informed Samsung about that, and the Samsung released the patch for this problem in January 2017.
Yeah, and a problem here is if your organization register domain under second level domain, like com.au, com.ua, co.nz, or whatever like this, then someone can register after discover domain under the same second level domain and run HTTP sync servers there and receive all requests from all these vulnerable clients. And all these requests will carry user credentials and email address. So you get it for free.
Guess who registered this domain name? The second thing, what we found that when we was testing out the magic list of the non-really standard email addresses against the iOS devices, we found out that in case of the to add in an email address exist, So then the iOS device making the run request as well. So the calculation of the how many add characters at the email address is run by Apple, and basically then the request done to the not to the autodiscover dot domain name. The request will be done to autodiscover dot top level to TLD actually.
Yeah, so this email is completely invalid. So first of all, they should not allow user to enter email like this. And what they actually do, so they take a com as their domain part and send a request to autodiscover.com or any other top level domain, right? When we looked into a list of Mozilla public suffix, and there is about like 8,000 different second level domains, and IANA TLD list contains about 1.5K domains as well. So it gives us about 10,000 potential after-discovered domains, which you can register, run HTTP sync there to see how big is a problem. And this is what we decided to do actually. So we decided to register, 26 domains and run a simple HTTP server and accept all requests wherever people will send us.
So domains we registered was not really like random. So we predicted that these domain names will have a most impact of this problem.
Yeah, so if you go to, let's say, Shodan and trying to find how many people run after this Exchange server for, let's say, different country, you can easily find these stats to predict which domains will be most useful for this. Yeah, so it's easy to obtain certificates for these domains because it's absolutely legitimate. We don't do anything non-legitimate in this case. And we started to collecting data, and it just basically
it was a bit different way. So actually, Ilya, we registered these domain names. We make up and running our sync service, which was receiving requests, which we expected going to receive requests. And as soon as we registered first domain name, configured the certificate in the proper way, I think using like a bot cert and whatever. So Ilya called me like at 3 a.m. in the morning saying that, hey Max, we have a traffic. So, and the most difficult thing was
that I really cannot fall asleep after that because I did it like after work. It's probably finished at 3 a.m. And after I just started and I looking into access log of Nginx server, I see like hundreds requests, and it's like more than 10 requests per second from different clients. And you see it's mostly Samsung devices, and I have to scrub all these emails actually, but this is the real emails from real people. So if you want, we would be able to receive passwords from these guys as well, like easily. We just don't need to.
You haven't mentioned one thing. So why he couldn't get sleep? Because when we seen these requests, with requests not only like just simple requests with the email address. In some of the requests, we've seen also encoded passwords as well. So that's the most problem.
Yeah, so we ran this HTTP sync for several months. So we registered 26 domains and received about like 13 million requests. And 70% of all these requests carried users' credentials, username and password. And so it's about 2.5K different user agents affected it. The number is really big because diversity of Samsung Android clients is really huge. So if it's just like one model, like Samsung H7 or whatever, it can be different for different markets like US, UK, Asia, Australia. So it's like one model, but they already have like 5 or 10 different user agents.
As I mentioned before, the Samsung and Apple, they released the patches. So actually Samsung released the patch in January 2017 this year. And patch was, I mean, the Samsung was good in communication, so they really told us that they're going to make a patch. They released it. The patch was, I mean, updating some of the devices. My main problem with the Samsung, that not all the people making these updates. And we see the traffic up till now. Traffic going a bit lower, so it's not like several requests per second, so it's maybe several dozen requests per minute, but still we see the traffic. So the Apple also released the patch right before our presentation on BlackHat Asia, and the patch was an update of the iPhone 10.3. It was like just a few days before we agreed to disclose it. And for Apple devices, a bit better because we don't see much traffic now from Apple devices because most of the devices, I think, updated with the patch they released.
Yeah, there is more data about like trends and user agents, and you can find it in our white paper. It's published on a BlackHat Asia website. There is like more technical information about all this stuff. So if you want to know more, I suggest you to download it and read. So let's talk a little bit about mitigations, how we can mitigate this thing, right? Accept get patches from different vendors. So first of all, if you're using Samsung devices, you gotta be update to a latest version what they have because they already patched it, so you will be not vulnerable to this issue. If you are responsible for security in your organization, I better check all email clients you guys using in the similar way to find out whether there is some vulnerabilities, because we didn't check all these clients. There is like not hundreds, but about 100 of different email clients that can work with Exchange Server. And I bet there is much more vulnerable email clients that works in a similar way.
Also, maybe with our research, we haven't seen everything around bad domain names because we're just only 26. And we did it as independent researchers, so we don't have like a big budget for that. But still, I mean, in case of your enterprise, you can also check your outgoing HTTP logs for the requests to auto-discover domain names which should not be done to, I mean, open internet maybe. So you can determine the clients which are affected by this problem.
Yeah, so, and since there is like a couple of open source implementations of auto-discover client, not for a client itself, but for servers that work as a client for Exchange for a different thing. And we found some of them requesting or sending requests to our sync servers. So if you are developing something like this, it's better to just read all the documentation on Microsoft websites. They have like plenty documentation about auto-discover, how to do it right, how to do it wrong, and they have like their own libraries written in .NET, but you still can use them. And I think we put this recommendation for ICANN to ban auto-discover, new auto-discover domain registration, but I guess nobody will do this as for WPAD. So anyone can go and register from all this like 10 canned domains and see.
No, I mean, communication with the ICANN was kind of successful with WPAD, so I was able to provide the ICANN the idea that this domain collision should be shut down. And most of the WPAD domain names, which I was able to register last year and make use of it to collect several million requests with the traffic from these domain names was blocked. But about auto-discover is a bit different because this problem is not as loud as WPAD was last year. And up till now, like we're working at a startup, and this startup doing a lot of things with credential stuffing, with access credential things. And we always, I mean, see the leakages in the underground, people talking about how to hack, how to buy lists of the email addresses which is stolen. But I mean, in most cases, it works like people doing like some kind of phishing or accusing this information via the botnet. But this way, like in case of you just go and you know what kind of domain name you can register, you can receive login, usernames, email address, usernames and passwords without any problem. This is, I think, for ourselves, it's kind of a new way how you can earn money just knowing the domain collision, which can bring you a lot of traffic.
Yeah, so to wrap it up, if you have to work with emails, you have to parse them. Please read documentations. Please read recent RFCs. There have been like 3 iterations about like all these protocols which work with emails, and they cover most of all these edge cases and scenarios. And I also follow documentation from vendors. They have a pretty comprehensive documentation, not just like a simple protocol implementation. And yeah, nobody's perfect. We all do mistakes. Let's learn from each other. And thank you. If you guys have any questions, we'll take it after that. Thank you.
All right, rolling on through. This is Patrick Thomas.
Maybe I'm not set. What are you supposed to plug into up here? There we go. All right, cool. All right, got a bunch of material to go. So how's the volume? Is that in the back? Okay, cool. All right, this was originally about an hour-long talk, so I've chopped it down. I'm not going to cover stuff in as much nuance or all of the details that I want to get to, but I'll be available afterwards. So definitely, please come hit me up. A little bit about who I am. Patrick Thomas. I work here at Netflix. I'm coming up on, or I'm just over the 3-month mark now. And the road that I got here informs a little bit of this talk. I was originally a developer, and then I started doing pen testing, and now I'm doing AppSec, kind of that security engineering type stuff. And the thought process there of that both people on the defender side need to be thinking about what attackers, how they look at those systems, and also an effective attacker these days really needs to be far more immersed in the actual technologies and sort of where the bodies are buried of these tools. So sort of to that extent, I want to take a little bit of check on the room real quick of who here sort of primarily considers himself a developer. Kind of like a quarter, third. Who considers themselves a pen tester? Couple of people. And then who's doing like AppSec or security engineering type stuff? Okay, so good mix. Part of this is going to be those people need to spend a lot of time talking to each other to be more effective at the things that they're doing. And then credit where credit's due. I originally developed this talk with a friend of mine, Alec, who you know everything about him from his Twitter handle there. So he's a cool guy. You should also follow him. Getting on to, like, where did this talk come from? Two things put together defined this talk. This sort of line of logic of that there are all of these technologies. There are developer productivity technologies, there's automation technologies, there's deployment tools, and there's so many of them these days, and there's so much magic in there that it's very easy to not peek under the covers and take a second thought about what is that magic doing for us, and what is that power potentially handing to anybody who gets access to this tooling. And then the specific example from it was a pen test that I did in my previous job, my previous role, that just kind of got way too interesting way too quickly. Kind of the holy crap, what have we owned? So here's the setup. This was a typical service provider running a lot of services out there, doing some mobile stuff. They had done so many things right that, you know, we really wanted them to come out of this clean, but this left kind of only looking at application attack surface. Did, you know, one kind of obscure thing wrong, gave us code execution on a machine. We start looking around. We said, you know, what is this chef thing? This seems, you know, seems like it could be important. We'd heard of it. We knew it was this like deployment technology, so this isn't so surprising. But when that's all you've got, that's, you know, that's the sort of the thread that you pull on. Pivoting through that, looking, we say, okay, we've got this big piece of infrastructure. No necessary surprise here. If you're deploying with Chef, you've got to have a Chef server. But, and this dates this original talk a little bit, it was heartbleedable. So we got into this thing, we got JSession IDs, or got session IDs rather, and start looking around. But this is where it started to go off the rails. This was essentially two mistakes in an organization that was doing a ton of things right, and we're in, and we're looking at these things called data bags, which is if you have important configuration information, credentials, keys, those kind of things that you want to imbue onto a running instance, then you can configure them here and give instances that have this profile access to this kind of data. And that stuff, that's really kind of all the keys to the kingdom all in one place if you have access to these. And it kind of gets slowly worse and worse and worse as we're looking at this. And then pretty soon we realize that we have the keys to manage the Chef cluster themselves because Chef was managing Chef, which is sort of an interesting arrangement there. And basically remote code execution across every machine in their fleet. And where we were at with our sort of slack-jawed expressions here was, how can a company that really only made two mistakes have given up everything? And that's a kind of power that you really wanted to delve into and care a lot about. And this was also a technology that we really weren't familiar with at the beginning of this engagement. So if this can't be the only one of these technologies, and also this can't be the only company. Is this normal? Is this what we should expect from a very DevOps-y, modern, automated deployment perspective? If so, this isn't the future that we want to get to. So that leads us kind of into the themes here. These are powerful, centralized tools. Whoever has access to them has all of that power. So we need to care very deeply about sort of the promises they make and are they defensible? I talked about magic, this idea of when a tool does a lot of stuff for you, maybe you don't peek at it. If you're deploying from just a couple of random shell scripts that you had to hack up and sweat over every line, you probably have a decent sense of how they work. They may be crap, but at least you know what they do. Versus if you install some glorious magic deployment system, maybe you didn't look at all the bells and whistles in it. And a point, because I'm going to dump on a couple of things, I'm very bullish on the power of DevOps and modern deployment and immutable infrastructure and all those kinds of things as awesome security tools. But the point is that we want to make sure that we get these as right as possible and understand where that power is coming from. So kind of had material on a bunch of this, told you that I had to cut all of this down. So from all of these, I'm just going to talk about these here. If you're interested in some of the other ones, if you use them in your organization, hit me up afterwards. There's other stuff. And I'm not going to be able to cover this in as much depth, so I will skim over a couple of things. start off with Jenkins. Hudson Jenkins, hands up, familiar with it, use it? Good, everybody. Realistically, if you didn't put your hand up, you probably use it somewhere. It is the controller. It is the heart of sort of modern deployment infrastructures. It's the place where we go from messy developers doing messy code type things to beginning to put things on the path to going out to deployment. So we should care very deeply about what goes on in our continuous integration server and who can do what there. So for each of these, I'm going to really quickly hit identifying, attacking, and defending, just to make sure that everybody gets one. So the identifying is coming a little bit from the pen testers or the external adversaries perspective where, hey, does this organization rely on this technology that I might be interested in? Jenkins is phenomenally helpful in so many ways. There's really good reasons that people use it, but one of them is advertising its existence. If you're in an environment and you're a pen tester and you start looking for any of these telltales, you'll be able to quickly find Jenkins. It responds with X-Jenkins headers. It has all of these ports, but these down here are delightful. You don't even have to scan for it. You don't even have to bust out Nmap. If you can do a DNS service discovery and broadcast out, it will tell you that it's there. So you can very quickly discover these things on an environment. All right, attacking. This one is probably, I think, the most powerful one and the one that surprises people the most of Jenkins absolutely has remote code execution built in as a feature. Out of the box, good to go, let's rock. Because that's a useful thing to have on your build server, but many people have never heard of it, many people never use it, many people don't realize that that's a thing. If you go to, on your Jenkins server, /script or /text and post to that, you'll get code running. And of course, there's a Metasploit module because there's a Metasploit module for everything. Also, any build configuration can put shellcode in there. That will run somewhere, not necessarily on the server, but that will get run somewhere. You can put all sorts of things in there. There's also important details in these, which if you're not looking to write but read, people will include all sorts of stuff in these details. Sometimes passwords that they don't want baked into the code, but that's needed in the build. Those sorts of things. So what does that /script endpoint look like? It takes Groovy, which not many people write Groovy these days, but here's a great opportunity to write some Groovy, and you can run it. And on Windows, Jenkins installs as system by default, which I do not know why, but there you go. So anybody who's doing sort of pass the hash type stuff or Mimikatz, any of those, Jenkins, Mimikatz, domain admin, done. And no CSRF token. So this is CSRFable. If you know the Jenkins server in a company and a little bit about it, you can execute code on Jenkins through people's email, which is pretty awesome. Just recently, and in the trend of things are getting better and security tools are getting smarter and caring very deeply about this, modern installs of Jenkins have the CSRF stuff turned on by default. It does support it. Previous older versions didn't, and when you upgrade Jenkins, if you're coming from an older version, it doesn't have that flag set. So if you've got a Jenkins server that's been around for a couple of years, maybe go check that config. You probably don't have that setting. So quick, simple CSRF. Also something that surprises people because most of us spend our time as authenticated users on systems. And this is where seeing a little bit of the attacker's perspective helps. If you're not logged in, the default behavior for Jenkins is to allow browsing of workspace artifacts. This is actually super important for fetching build artifacts and doing other deployment stuff. But it means that if you're putting important things into your built artifacts, such as config files or passwords in code, which we shouldn't be doing anyway, but does happen, any of those kinds of things, unauthenticated users can browse through these, and if your source code is in Java or Python or Ruby or one of those languages is very easy to reverse, then unauthenticated access to Jenkins is as good as access to your source repository. And that, I think, surprises too many people. Then they're getting better at this now, but Also, something that surprises people is that slaves can send commands to the master. So that is command execution on the master from any kind of slave that you have. The example here being, an XP machine or something that that other people have admin access on, who you might not give admin access on the master to. That's a transitive relationship. It does honor that. Modern versions, you can lock this down a little bit more, but again, it's not the default. Defending. Jenkins, I think it's 2 and more, has built in a bunch of these different security things, but so that they don't break anything. If you're upgrading, they're not going to be on by default, so you should definitely add these. There are more complex authentication mechanisms than the default ones that come out of the box, so definitely look into those. Enable CSRF tokens, and then also check your plugins. You can have a totally up-to-date Jenkins and a whole bunch of really old plugins. Okay. Docker. Who uses Docker? Okay, decent number of people. Would have expected more. Okay. I think the important thing is many people will treat it like a VM. It's not a VM. It's freaking magic. It does so many cool things that can be VM-like, but it's not the isolation that you want for untrusted processes or for processes for tooling that you wouldn't necessarily trust. If you're pen testing, if you're getting access to a box and trying to say, hey, is this involved with Docker? There's a couple of like telltale files and processes that you can look for. If you think that perhaps you might be on a Docker host, there's these telltales to look for, or if you want to prove to yourself that you've broken out. And then finally, if you're nmapping and scanning for Docker registries, that port 5000 or that curl, that's how you talk to a Docker registry and get it to come back and say, yep, that's what I am. Attacking the container breakouts. I said they're not VMs, so it's really important to realize that any syscall is potentially a way out of that container. There was the one called Shocker in 2014. It was an easy way to drop out. We all heard of Dirty Cow. That's a little bit more recent. Any of these kinds of things that access system calls are potentially a way to violate that magic trick of running in a machine but not in the machine. If you're on a machine, some ways of passing credentials or important information, configuration information into a machine, environment variables, those kinds of things. So if you're pillaging around, make sure to check for those. Another thing that I find surprises people is that the Docker user is as good as root on a machine. So don't ever get cute or clever about letting people pass command line parameters or sort of arbitrary things to either the Docker command or as the Docker user, because this is sort of a trivial demonstration of breaking out of that using the abilities that you have for the Docker daemon. Originally, I had Docker defenses, but this slide got too long, and I think the larger point is that Docker defense is a huge topic right now. So I've got to slash through the slide so that I don't leave it as, yeah, this is all you need to do. It's a massive topic. There's a lot of things that you definitely want to start thinking about, but this is definitely not the end of the story. Getting out of Docker is, if you're running in Docker in AWS or something like that, these sorts of looking around once you're in a machine, looking around for these kinds of keys, either hard-coded or in configuration files and environment variables, potentially lets you immediately escape from a Docker container and get far more access to the rest of the environment. This is essentially duplicating the chef scenario that we had at the beginning of the day of I was in just an instance, but now I have ability to administer the larger cluster. So these shouldn't necessarily be available, but if they are, make sure that they're constrained. I was having some discussions with people earlier today, making sure that this is still true. If this is inside of a Docker container that we're hitting, and you have something like XML entity injection. Familiar with XML entity injection? Okay, not enough hands. it's really sick, especially if you deal with XML. This can just ruin a day. But if you can XML entity inject into a Dockerized application, then you can turn around, request this URL, which is the AWS local metadata service, which will cough up credentials that instance should have access to. And the important thing is, although we're going into a Docker container here, we're talking to the local metadata service on the host. So this is, in essence, a Docker breakout without ever touching Docker. And I just actually learned this very recently. This essentially works on Kubernetes as well. By default, it puts tokens that are available to the service accounts, maps those into a directory on the entire pod. So there's a tremendous story, this is how it came on my radar, of the BSides San Francisco CTF that just ran a few months ago. A contestant in the CTF used this trick to own the entire CTF, and there were a couple of really good security people running it, so I think this is going to surprise people as well. So wrapping back together on our themes. These are powerful tools. These are good things that we should use that let us do lots of things very quickly and consistently and reliably. But if attackers get a hold of them, then they have all of those capabilities as well. So put all of our eggs in one basket, but watch that basket. This is the magic part. Just make sure that we understand all of the different things the tooling is doing for us. Read the manuals, look at the sorts of things that it exposes. And then, yeah, do more of this. Just do it carefully. Skip over this, but this is sort of a where the bodies are buried if you're doing remote file includes or things like that. I've started building up this list. If you care about this kind of thing, come hit me up afterwards. Other than that, there's my time. Thank you all. Cool, thanks.
Same thing. This is Bryan Zimmer for our last talk, and then again, hold any questions. We'll do those after. We're gonna project demos, lots of good stuff. So.
Yeah, I wish I knew about the sushi ahead of time. I'm kind of full now. Oh well. Hey everybody, I'm Bryan from Netflix. I'm on the information security team, focused on corporate security. So I won't really be going into any sort of application testing stuff. It's more infrastructure. So I'm here to talk about our location independent security approach, or LISA. If you've heard of Google's BeyondCorp, it's a little bit like that. So as the name implies, it's a security architecture or security approach where we're trying to be independent of people's location. So in essence, stop trusting, just because you're on our network, you have an IP on our network, we should not be trusting you and giving you any special access, essentially turning the network into, your office network into a Starbucks network. It's just like any other network out in the world. So instead, we're trusting authenticated users, their identification, two-factor authentication, and the health of their specific devices. And this shares some of these basic principles with Google's BeyondCorp, although Google's BeyondCorp goes off into crazy levels of detail that I'll mention briefly at the end. So why? So traditionally in corporate environments, people would be able to plug into your network and get access to other workstations on the network, local servers, hop over to your data center, all sorts of fun things. So we wanted to address that risk, and rather than putting in something traditional like 802.1x, we wanted to step back and look at the bigger picture and say, okay, well, how else could we address this, and hit on some of these issues that I'll mention in the next couple slides. So in Netflix, we have a lot of what we call freedom and responsibility, and part of that is we really like having an open campus. We don't want, guards and crazy fences and, like lasers and sharks and whatever. So we want people to have fairly easy movement about the campus. So rather than focusing on physical security, we then focus on logical security. We also want people to be able to work from anywhere without geographic restrictions. So you have the same experience in Tokyo or McDonald's, or you're home office as you would in the corporate office. And also, all the cool kids have been saying it for a while, the perimeter is dying or dead, so we wanted to help put another giant nail in that coffin by taking away another part of that perimeter, which is traditionally the office network. Benefits, so reduced attack surface, so you don't have to worry about people coming into your building and plugging in one of those traditional attacks. Help stop man-in-the-middle attacks. I've had people ask me, what do you guys do on your network to help against like ARP spoofing and man-in-the-middle attacks and all this other stuff? And, well, now with this in place, we don't really have to worry about that. Everything from like layer 4 or so on down, we don't care if you man-in-the-middle us. We've got other protections to get around that. Because even if we had those protections on our corporate network, they wouldn't protect the user when they're, say, at Starbucks. So we wanted something that would work in both locations. This also provides a convenient choke point for authentication, access, and inspection. So rather than doing this at scattered places around the network, around the environment, the enterprise, you can do it in one central spot. And it also allows you to do endpoint checks for the health of the device, doing inventory, doing patching, checking all sorts of health-related things. More benefits, simplified network architecture. We wanted to help clean up our network and keep it as simple as possible, and have one solution that covers users, as I mentioned, inside the office and outside the office. Also, we have some locations where it's just a small office in the middle of nowhere, and we can't put in a giant network stack that we might want in one of our corporate offices. So we want to protect those users as well. And because you're not having giant security stacks scattered around your environment or at different offices, you've got cost savings, which is always nice. And this is all commercial off-the-shelf software. We're not doing any custom development, with one small exception I'll talk about. So since it's all commercial off-the-shelf, you just bolt it together. You're not doing any custom development, and I don't know if you're like many other companies out there, you don't have a dedicated team that you can, like your IT department doesn't have dedicated developers or people they can steal from production to help develop custom code to do all this sort of stuff. So you're saving time and resources there. And also because you're not doing custom development, you're not tied to a specific set of supported vendors. So if you swap out, like say your network stack or your VPN stack or whatever, or your endpoint health checks, it doesn't matter. You don't have to rewrite any code. So endpoint checks at Netflix, I mentioned that freedom and responsibility thing. So we encourage people to MYOD. I thought I made this up this term, but apparently not. I Googled it. Someone else mentioned it a long time ago. So manage your own device. So people can bring their own device or they can get one from us. But instead of us tightly controlling that system, we want them to have the freedom to do whatever they want and run whatever software they want, do whatever they want. And the responsibility of that is you have to make sure your system's patched and up to date and healthy and everything. So to let people do that, all this data from the different parts of Lisa feed into what we call user-focused security. My homie Jesse right there presented on Stethoscope and possibly in the future on TrainMan, presented on Stethoscope at ShmooCon recently. So check out the talk there, awesome stuff. I got a link here. I can give you the link later. And we've also got a Netflix tech blog on it. So what that allows us to do is when the user connects in, it takes an inventory of their system and says, okay, your system's up to date or not. Here's how you would go ahead and fix it. And lets them do that themselves rather than us tightly managing the system. And then for people who don't frequently get on VPN, our 2FA provider and Google Auth, because we're Google Shop for everything, also have some health-based checks for those SaaS users that don't usually need to use VPN. So here's a quick screenshot of Stethoscope. This was some of the custom code I was mentioning where we wrote this custom app. I mean, you don't need this for Lisa, but to help with our environment of having people do everything themselves, we did create this tool. So the basic idea is user logs in and they see, oh, here's my iPhone, here's my laptop, here's my other laptop. Oh, I didn't know I had this laptop. Okay, well, anyway, I can junk that one. So my main laptop, it's good, but say it doesn't have patches installed or maybe disk encryption is installed. So then you're able to click on it and say, oh, okay, well, here's why these updates are, here's why an update, auto updates are important, and here's the steps to do it yourself. Methodology. So the basic building blocks of Lisa were, like I mentioned earlier, the office network really only gets internet access and VPN. You don't get any special access to anything when you plug into our corporate network. There's also device isolation, which If any of you got hit by the recent Samba exploits, this is nice for that, so that hosts, if something gets popped, it doesn't spread around your network. So host-to-host isolation and also network-to-network, subnet-to-subnet isolation. And then private resources like Amazon, because we're an Amazon shop, or your data center are only accessible via VPN. You could also, in theory, use something like SSL, like Google's doing some SSL proxies if you want to go that route. So more methodology. So don't forget that just because you're deprivileging the office network, there might be still places where that network's trusted, like say, because you're coming out of the building's public IP space, it's natted out, maybe over in Amazon or some other provider or somewhere, you're saying your application sees, oh, you're coming from the corporate building, even though the building's been deprivileged, I still trust these IPs as you come out the internet interface. So I'm gonna allow you some special extra access or bypass auth or what have you. So don't forget to check for whitelists in your applications and your resources and things. And oh yes, redundancy and circular dependencies. Circular dependency is always a fun one. So don't forget that if you're channeling everybody into one or a couple redundant access points, to have them geographically distributed and everything. So, if you're having everyone come into one VPN access point, make sure you've got a couple of those. And then also, what if your VPN box goes down? Or what if your auth provider goes down or something like that? So you may want to have a physically secure room on campus where you can bypass some of these in case of emergency. Collecting use cases. So we didn't really want to send out a blast email to the company because, one, people ignore those kind of emails, two, they get annoying, they just get lost, whatever. So we actually went kind of like a gumshoe sort of sleuthy method. So I actually went out and I had to get out from behind my computer and talk to people. It was a little scary. Talking to directors and VPs and, longtime employees and people in the basement, like with suspenders and stuff, all the people that have all the hidden knowledge around the org, and saying, hey, here's what's going to happen. Here's what this project is. Here's why we're doing it. Here's how it might affect you. How do you think it's going to affect you? How do we need to maybe change your workflow a little bit without, making your life totally miserable? Do you know of anybody else that might have this issue? And then that leads into all sorts of interesting breadcrumbs and trails and fun rabbit holes to go down. So luckily, after we did this research phase, we found most employees only needed internet and VPN access, so awesome. But there's a couple of use cases that were causing some problems. So I don't know if you've heard, but Netflix has this cool app that lets you stream movies from TVs and devices and things. So the only problem with that is if you're in the building and you need VPN access to get to any sort of special resources at Amazon, like say your test harness or your code repositories, and the code's running on the TV or your Roku or your Apple TV or whatever, there's no VPN client in a Roku or a TV. So of course we had to make a couple exceptions. So yeah, for these consumer electronic devices, they need to talk to private resources up in Amazon. And on occasion, some of them, people will be developing code on their laptops and they need this test TV to connect to the code on the laptop. So that also violates that host-to-host block that we were talking about. So creating exceptions. Our network one has limited Amazon access. So for testing CE devices, like I mentioned, test harnesses and getting code that you need and pushing code up. And our other network is full Amazon access. So this is more like the traditional environment, like before we had all this stuff in place. And there's only a handful of people on that, luckily. So that's usually to deal with things like VPN client limitations, because let's say, oh, maybe your provider's Linux VPN client doesn't have all the feature parity that say like Windows and Mac do, which would never happen. Or say you've got some high throughput situations, like you've got video tester guys with data science-y people testing algorithms on giant gigabyte, terabyte files of video on their desktops, and they need to have just giant pipes to their desk. So yeah, with these two networks, we review access requests, track, and automatically deprovision them when they're not being used. So since these are exception networks, we want to tightly monitor and control them. Long-term, these will go away. We're working on some small little Linux gateways so that you can have this box at your desk, and if your TV or whatever doesn't have a VPN client, you auth into this box, and then it'll connect up to Amazon with a VPN for you, or you can take it home, get the same access there, wherever you happen to be. So here's a visual diagram for us visual learners like myself. The basic principle is, so here's your typical office network. So you've got your user. The first thing they would hit is the private VLANs, which does the host-to-host isolation. Then you've got the firewall ACLs for the subnet-to-subnet limitations. And then going over to, via VPN, over to your private Amazon resources, you've got your VPN concentrator, and the actual client health checks are happening on the VPN concentrator. And then you've got your IDP and 2FA for verifying that the user is who they say they are aren't just using some stolen credentials or something. And then you've got your main network security stack where you do all your traditional network-based inspection stuff. And then you go out to the internet or into your private Amazon resources. And then, let's see, this is just a diagram here of the allowed flows. So workstations can get out to internet and VPN and then over to private resources. You can also come back down into devices on the local network. And then on the exception networks, you can talk directly to a small subset of Amazon and can talk device to device. And then here's the basic idea of host to host isn't allowed, subnet to subnet isn't allowed, and then direct access to private resources is not allowed. So pilot networks, it's always good to test ahead of time rather than just throwing one giant switch and having the building catch on fire or having people like slash your tires because you ruined their day. It's best to have like a small little subset of people to test things out, work out issues, tuning the workflows and documentation like, oh, we forgot step 5A or step 6 doesn't quite work so well with Linux. We need to tune that or have some workaround. And then, of course, always finding hidden use cases, because no matter how much you've communicated with people and tried to find all those use cases, there's always going to be something you didn't find or they forgot about. They're like, oh, yeah, I forgot about this one thing, but that only happens like once a quarter. Yeah, so all that kind of stuff. Automated deprovisioning. So this is just a quick description of how we do the automated deprovisioning. So just talking over API to our network switches and saying, hey, who's on this exception VLAN? The interface description says, okay, here's the jack number. And once we have the jack number, we can match it to cubicle number. And then from cubicle number, we can talk to Workday, our HR database, and say, who's in this cubicle? And then email that specific user and say, hey, are you still using this? Or, hey, this hasn't been used in, say, a month. Can we automatically deprovision it? You know, hit yes or no. And if they don't do anything, then we can automatically deprovision. Communication. So at Netflix, typically what happens, I'm oversimplifying here, but when we have a new big idea like Lisa or some other strategic initiative, we'll put together a memo spelling out, okay, here's the general idea, here's why it's good, here's why we went this way, and then we'll have a tech strat where we get together and debate, okay, how else could we do this, or what are the merits of this? Is this worthwhile? Is there some other way we could do this? That kind of thing. And then once we settled on this approach, you know, it gets communicated then from the VPs down to their teams and then to the individuals from there. Always make sure that you pull in the right teams. So for this one, we made sure we had the security teams involved, the network team involved, because they're of course doing all the network changes, the help desk, because they're going to deal with the users that might come in, and then the people that are going to be affected most, the different teams that you know it's going to affect their workflows, or people on the exception networks. So different ways of communicating, since we had to get creative, since we weren't just going to send out a blast email like I mentioned. So we had to do targeted emails of finding out all those use cases, then emailing those specific groups and departments saying, hey, for your specific group, this is going to happen. And then setting up flyers in strategic locations to hopefully catch everybody. And what is the one strategic location that everyone visits every day unless you're some sort of freakish camel? The bathroom. So that worked well. We also had a Google group. We had a Slack channel because we're Slack shop for the most part. We had a question and answer doc where people could post questions and answers. We had a website. We probably would have taken questions over postcard if we could have, like any method possible. And then we had town halls where it was basically in this room, and we announced, hey, if you have questions about Lisa or concerns, come talk to us. It went well. I made it out alive. And then we also had office hours every week. Kevin, no, you remember these. Good times. where you would post up in the cafeteria and put up a sign and say, hey, these are Lisa office hours. It's scheduled every week from 1 to 2 or whatever. Come ask any questions. And then we also had a day of the war. We had a war room down at the help desk so that when people would come into the help desk, we were right there with them, seeing, kind of like having our finger on the pulse, so to speak, getting everybody in the same room, those teams I mentioned, like security and the network team and help desk and all that. And then it's time to go live. Did you get everyone? Are you sure? And yeah, you think you get everyone, you do all you can, and then there's always that one guy that, like the guy that a couple days before we went live, he comes up to me and he goes, Brian, what's this Lisa thing I've heard about? I was like, you didn't see the flyers? He's like, oh yeah, I saw the flyers, but I didn't read them. I shed a tear. It was hard. So at our Lisa office hours, I put up this poster to try to get people's attention. I also had a little stack of beer to like entice people in. They're like, oh, free beer. Maybe I should learn about this thing. Unfortunately, it was mostly my coworkers that came around, but at least they helped drink the beer. And then branding. Every cool project at Netflix, especially the open source ones, have to have some sort of logo or mascot, a giraffe in the case of Stethoscope, or just cool logos. So one of our internal UI guys, I had him do up a logo. He actually did the Spinnaker logo too. You can see a big resemblance there. So that helps with tying the messaging together, like when they see the flyers, when they see the email, when they see the website, when they see stickers on laptops, my tattoo, what have you, they get the messaging all tied together. They know this is all part of the same project. So beyond this is where I tie in BeyondCorp a little bit. So as I mentioned, it's similar principles to BeyondCorp, where you're deprivileging the office network. You're trusting, you're instead trusting users based on their identity and the health of their devices. So Google goes, of course, as Google does with their bazillion developers and PhDs, to the next level. And so you can read their white papers on this stuff, and it's awesome. Like, it's a superb architecture, but it's a lot more custom. It's a lot more work, custom code and everything. They also have very tight endpoint controls. And I read somewhere that like even if you swap out the RAM chip on your motherboard or whatever, like it revokes the cert because it's like, oh God, this might be like a new system. We don't trust it. I don't have all the details on that, but that's what I read or what I understood in the white paper. So it's definitely a bit more, yeah, not really so Netflixy. So we wanted to go something a little more friendly. And they also put proxies instead of their apps. So basically they make their internal apps web accessible rather than using VPN. So there's of course always trade-offs to VPN or to the proxy approach. So pick whatever floats your boat. And yeah, so Lisa has similar principles, but a smaller feature set compared to BeyondCorp. But it could be a stepping stone to BeyondCorp, because we are actually, maybe the next step, we're looking at possibly doing the SSL proxy approach rather than VPN, just to get better performance and impact users less. That's it. I'll take questions outside.
For 6 years.